And one of these things is this config command. What we have in here is the config directory, and this config directory has a whole bunch of things that it sets up for us. It's checking if a specific wash directory exists, gets the configuration directory inside of the wash directory. And the reason I chose to go with this is I started looking at some of these commands that might be fun to like move over, and one of them was drain. And inside of drain, we have these things where we've like pulled in like a configure, and then we have some other things down here that look like oh, look, model cacher and downloads, or all these things sound like pieces of information that you would want to use. So the first thing I do when I'm creating any sort of REST API, and especially when I'm refactoring from an existing thing like this, is I say, what's the type of information that people are going to want to see? What's the thing they're going to want to consume for their library? Because most libraries are used to be extension points for something else. Almost everything I've ever used has been used that way, and anything that I've had people use in mine is also used that way. So I want to think of information that I can basically export for users to have available, whoever consumes this eventual crate. And so my first thought was, well, we need to create a config module. This config module will have all these kind of constants and directories and those kind of things. And so I created config.rs and I copied over what we had. Now, the first thing I did was I started looking around, and I'll actually, I'll do this. I didn't do too much. So I'm just going to copy paste it from here again, just so people can see what logic I'm following here. So inside of this config.rs, the first thing you do is you create a config.rs, and then inside of your lib file, you have to say that there is a module there. So this is for those who aren't familiar with Rust, just so you know, like you have to say, I have a module, it's called config. And Rust will look for a folder that's called config with a file called mod.rs inside of it. You can see that right here on my left sidebar with the start thing. There's a start mod.rs, or it will look for a single file named config.rs in this case. So I'm going to start with just a top-level file. I could be wanting to do this in more files later, but we're just going to start easy and then expand as we need to. So what I've done is created this. And the first thing I look through is I say, okay, we're using this anyhow result type. Anyhow result is kind of like a catch-all error that's a lot easier to use than the like error trait. It still implements the error trait in Rust, which is the thing pretty much any type of error should be implementing. But it kind of is a free-form error. You can add a lot of like call stacks and other things to it, but it doesn't necessarily provide a lot of context without looking at the message. And so this is great for things that are going to be consumed from like a CLI format, or things that might have multiple types of error cases that you can't capture all of them into a single thing. So here, though, if I'm looking at this error, we're using this IO error kind. And so the first thing I'm going to say is, well, look, looks like this is going to be returned as an IO error, and this is going to be standard FS creator all also returns an IO result, which is IO result. It's just a result with a response and an IO error. And so my thinking is, as a user, if I'm consuming this and this is creating things on a file system, I want to know that it's a file system related thing. It's IO related. And so I'm going to swap that and say, we actually don't need the anyhow result. We're just going to use the standard stuff. And I'm going to change this to result path buff. And actually I can do IO do result, and then as IO result. And I'm going to say IO result and return a path buff. And so that way, everything now just returns an IO error.
So Taylor, you've said a few things about like anyhow results and like standard results or standard errors. So I guess I have two questions. One, is anyhow not a part of the standard library in Rust? And why would you, if there's we already had this anyhow error, why move to use kind of the IO result here?
Yeah, so anyhow error is something we're going to continue to use throughout this crate. But in this case, everything that we have so far is IO results driven. And I also know, this is just from me having done a lot of Rust, I know that the other things that we're doing where we're fetching directory stuff, is also going to be IO errors if they don't exist. And so what I'm going to do is just start with that because it is the most logical error. So someone who uses this can now handle it very specifically based on the kind of error that happens. They can tell a user who consumes this, oh, sorry, like I tried to create this directory, but I don't have permissions, rather than just wrapping the error. And you can have it can respond to it in code. The message out to the like end user who consumes this will still be readable no matter which one we use. But for a developer, I'm able to say, oh, this is an error kind like not found. I couldn't find this thing, or I couldn't create this path. Um, all of those things are being done here.
Gotcha. So we can, like, since we're making this a reusable, like a library that other people can use, like we can communicate a little bit better about what's happening instead of just we're using it internally and we know what could happen. Cool.
Yep. So right here, I'm going to do something else. So you're going to see also some of my programming idiosyncrasies. I hate wrapping on 80. I prefer wrapping on 100 at least because we aren't stuck to 80 column terminals anymore. So I always wrap those to there. It just seems to be one that I've standardized with other people who I've talked to about it. It's not actually a standard. So this in Rust, if you're not familiar, a triple slash is a documentation comment. This gets turned into the documentation you see in crate documentation online. This is auto-generated and created for you. The other thing I'm going to do is I'm just going to start off by adding a little bit of what we call module documentation. And module documentation is a / bang. And when you do that, it's saying this is the documentation that goes to the very top and describes what this module does. So I'm going to basically give a quick description here of what this module does. Love the comment there. Okay, so that's good enough for now. I'll probably update this with even more information down the line, but I just wanted to start with that. So this was just the first thing to copy it over. Now, because I want to work on this drain command next, I'm going to start pulling over some of the stuff that's in there. Now, there's a question here that popped up in chat, and I wanted to address that one real quick before we do it, and it's right on your screen. So we have this idea of if a struct uses lots of option types, or even nested structs, like when you build a library, what's the best way to deal with these option types when nesting other structs? So it really depends on what you're doing with it. So there's some that they have to do it by nature, and you just end up with this really long stream of handling options. One of these is, for example, the crates that deal with Kubernetes inside of Rust. I actually really like Kubernetes code in Rust. It's a lot cleaner. But the problem is because everything's optional, everything is wrapped in one of these options. So you have to do like unwrapping of all those options down the line. So the best way to deal with it is to try to abstract it away from the user is what I found. So I don't know if we have an example right here. Let me go back to the config because I know we had a few things. So we have this. This is just error handling right here. But let me see. We actually might have one. There's a lot of code in here, so it might take a second for me to find it for you. But yeah, we'll see if we can get to it. But basically what I do is I try to wrap things in with helper functions that can unwrap you to the specific thing. So we did this. Actually, I do have an example I can pull up from Crestlet. So let me go ahead and Crestlet is another project that I did a long time ago. At this point, I started a long time ago with some of my other coworkers around running wasm inside of Kubernetes. And so we've kind of like moved on since then, but I will go ahead and find the code and then zoom in so everybody can see it. But one of the things that we have inside of here is the kubelet. And inside of kubelet, we have, I believe it is the pod mod, as we like to call it. So what we've done in here is we have the kube pod, and kube pod is the actual like pod object. and it's a little bit gnarly because there's so many different like sums and things you have to get through to actually get the data that you want. So what we did is we created a wrapper around it for creating this data. So this is just only if you're consuming data that you do not have control over. If you have control over it, you can probably find ways to eliminate the need for options. But here we do a bunch of things where we like go down and we deref it and try to get it out, or we're able to then go down and unwrap down the line. And it just return this little helper thing right here, this question mark is called the try operator. And when you use a try operator on an option, as long as you're returning an option, if it gets to it and it finds that there's a none, it'll return a none. And so we tried to like basically abstract over this as quickly as possible. So anyway, that's just an example. But we'll go ahead and go back to the code here and kind of show like what we're doing next. So that was a great question. So first off, there's a couple things of data here that we're looking at. One of them is like where are we caching our models? I'm guessing, and I haven't looked yet, is that we also do some validation of models inside of we do some model validation inside of Wash, and so I'm going to go ahead and check that, and it is Wash inside of Smithy. I'm assuming there's probably something in here that's similar. I'm not going to go try to find all of it right now because I'm not refactoring it, but basically I'm assuming this code is likely to be used in more than one place when somebody uses this as a library. So I'm going to take these two things right here, and I'm going to go ahead and put them inside of the config module I just created up here. So first thing I'm going to need to do is do a pub on these because I want them to be exported for people to use. And then right now, I'm not exporting the washer constant because I figure that this is one where we want people accessing it as an actual path that we get back, which is the whole configure thing. So the configure actually creates it with like washer and then does the actual path for you. So what we're trying to do is give people the right tools to have here. So we could give people raw strings, but if I'm making someone manually put stuff together that they might use, then for me, that's an indication that this is probably the wrong way to do it. So for me, I expose it as things they can use, which is in this case, getting a config directory, getting cache directories, and getting the download directory. And you'll notice that this thing also calls the configure. Now, what we're going to have to do now is this is a great example of a refactor when you refactor code that's from a CLI into a library. As a library, this makes sense. We can just print a line and say, hey, sorry, I couldn't get any like downloads directory for you. I'm just going to return nothing. So that's not going to fly here. So what we're going to do is also make this an IO result with a path buff. So what we're able to do now is actually do an unwrap or an error. But like right here, we're just matching the configure, and we're doing a join with it. So what we can do is replace the entire match block with something that's really cool in Rest, which is the idea of mapping a result. And so what we will instead do is configure dot, and then we're going to go ahead and unwrap that. So that will return an error as the right type if it is an error, and then otherwise it'll continue on. Actually, no, I'm going to do this a little bit different. I'm not even going to do that. I'm going to say map. And inside of here, so a map takes if the result was okay instead of an error, it's going to return, it's going to put that type in here, and I'm going to be able to map it. So I'm going to take that path, and you can see the autocomplete's telling me that's a path buff I got, and I'm going to do p.join and do downloads dir. And so then this joins with the with that thing. So basically, I'm going to get a new directory out that's still a path buff, but it's going to have this new download dir created. And then I can just return it because right now this is an IO result with a path buff on the inside. So right here, I can just actually map. So I just now turn that into a one-liner. So if you're not familiar with Rust, this mapping functionality is very useful. It takes from the ideas of functional programming languages and it puts together this kind of pipelining things that you can do with the data. And in this case, we're actually doing that here. So that one. We solved it here. Now we have to do the same thing up here with the model cache directory. So weld cogen is something that was pulled in there, but I don't think we have inside of our thing. So right here, this is the cargo.toml for the whole thing. And we have a weld cogen right here. And I'm not going to worry about update. This is telling me it's not up to date right now, but we can do that later. And so over here, I'm going to look and I can see I don't have weld cogen. So I'm going to come over here and add weld cogen and save it. And then cargo is going to pull down the things I need. And then over here, as soon as it finishes running, it's going to be able to tell me and generate what the result type is for weld caster. While that's compiling, we'll go ahead and come up here and say, okay, this looks right. So we have a pub, we've exported it. We're not exporting wash directory. This is ready to go. Now we can go ahead. Okay, so I just double checked to make sure I did everything right there. I'm going to check one more place actually while this is going on. I think there was a. So there's stuff here in util that looks like it could come over here. Now the reason I always look in util things because they always become kitchen sinks no matter how hard we try. And over here we have this idea of okay, I have a bunch of default ports and things and timeouts that I need. So this is common configuration data when you're doing stuff inside of Wash. Now, some of this might not be applicable everywhere. So I might split these up into separate files and include them conditionally depending on feature flags in the future. But for now, I'm actually going to copy these over and put them inside of the config thing here up top. So these are all of our pub consts that anybody can access and have them available. So that's just something else we're adding into the config. Now down here, we see this weld caster returns a result of a path. Let's check what kind of result. Oops. I'm just going to go to weld caster, and this result type is looks like our error. Yep, so it looks like a weld cogen error. So because it's not a weld cogen error, because it's not an IO error, I'm going to actually have to like manage this a little bit differently. So once again, I'm going to do the same mapping thing I did before, but I'm going to have to do two different maps this time. So I'll copy this, and I'm going to get the caster. And then I'm going to say map. Oh, actually, no, sorry. Wait, we don't even have to map the first one because it's already a path buff. So if we get a path buff, that's all we need. So I'm going to do map error. And in this case, I'm doing the same thing that I was doing before, but I'm mapping the error that came through. And in this case, it's the error for a weld, for basically wasmBus RPC. So I'm actually going to go back to that. And, oh, here we are. So here's the error. And here's the different error types I'm looking through. So I can like check like what this might be. This is where I think we could improve our this is a library that we this is a library that we maintain, and I should probably fix this so it's a little bit more clear about like what this thing can return. But it looks like we get an error other here, rather than like doing something else with it. So we're going to go ahead and say, okay, this is just another error that we're going to get. So in this case, because it's likely some sort of underlying directory error, which we were not clear about in our own error, I'm going to say, let's map this as an IO error. I'm not going to do something else. I'm going to do the same thing. It's going to be IO result path buff. Because I don't want, this is actually another design consideration right here. I do not want people to have to know about the underlying like wasmBus, RPC, like some of the code. And like people don't, I'm trying not to expose too many types to a user. And so here I am making the conscious decision to say, I am going to take this and I'm going to turn it into a type that the user's already expecting from the rest of these functions. I don't really want to mix error types. So I'm going to do the same thing like I did here. I'm going to say error new, and this is just going to be error kind other because we're not exactly sure what it is given the library we're consuming. And then I'm going to pass through the error message here. So actually what I have to do one more step, sorry. Oh, actually, I can do this simpler. I'm going to say e.toString. So all errors implement toString, and so you're able to then like format them just like you would a string. Now, sometimes there's some intricacies around there. So that just did it all. I just mapped the error, and now I can come back here and delete all this and go ahead and save. The cargo formatter will run for me. Oh, and this says, hey, I can't find downloads dir. So I know exactly what happened here because I copied it from the drain command. And we have a downloads dir that we imported. So we imported this from up. So this is actually inside of this code right here. And we have that. Actually, I can find this simpler. I'm smart. I can use my editor. Okay, so right here we have this config.rs inside of it. So a lot of this stuff right here could probably go um, inside of somewhere else, but I'll have to look because some of this was specifically made because it is specific to the wash code and not to everybody else. But this, however, is a pub const that seems like it should belong in our config. So I'm going to go ahead and pull it up to here and do my downloads directory. So now I can save it, and I should have no more errors after that. Oops, I did not save. I accidentally hit a character. There we go. Okay, so now we're all saved. So that was just the first draft of doing this, and I'm going to, I think there's some questions coming in that I can go ahead and answer.
Yeah, yeah. I will start with that. I actually have a question, but we can do that on the way back. So it came from someone pinged me in the wasmCloud community Slack. They don't have a Twitch account, but they were wondering what factors should someone consider when you're trying or when you're deciding to create functions as methods in an impl block, or kind of just what you're doing now, which is just plain old functions. Like, how do you kind of decide between those?
Yeah, so that's a really, really good question, actually. And the way I approach this is more of a question of, am I getting a single piece of data or is this data related to something else? And so for me, all of these functions are a single piece of data. I'm looking for a specific cache directory. I'm looking for a specific downloads directory. I'm looking for any of those kind of things. And so that's what I go for with this first stuff. But when we look, and I think we have some of this inside of a start, um, those actually might be mostly top level functions. This is really new. So some of this is not like, uh, here's a good example. So this is some of the parser stuff for the wasmCloud.toml that's used in wash build. And this is something where you have a common set of data that could be reused multiple times. And so um, the reason why that makes it really good for a struct is you're able to do like you're putting all that data together. So right here we say, oh, we have like config for Rust, or we have config for TinyGo, and we have config for the different things. And here's the project config, and then all this data. I think this one is mostly raw data, but if I then need, I'm able to use like an impl on it. Now to answer that question, once again, I can go to code that I've written before because, like I said, this is very new. You're getting like we're just starting to do this refactor to make this as real as possible. But this is from another project I have called Bindle, and Bindle's a really interesting project in case you're interested in looking at it later. But one of the things that we do in here, let's look. This is actually a really interesting one because of the signature code. So right here we have something called like a signature, um, and underneath, or sorry, signature role. This is the better one. The signature role defines a specific role that can be used um, for signing anything in a bindle. You don't have to know about it to understand this, but like for example, we're able to then implement traits on that type. And so that allows us to like print them in certain ways or to format or to like parse them certain ways. Um, but then we're able to do these things down the line where we have passing in specific types. So like right here, I'm doing an implementation on a type that allows me to do method that accesses that data. We also get this inside of, oh yeah, right here, key rings and other ones. So this idea of a key ring is pretty straightforward, right? Like you need a specific set of keys that you trust. and you're able to create a new one. And there is common data that's stored inside of this that you can access publicly. So this is configuration data like plain, but it also gives us some methods that allows us to consume or reuse that data. So we're able to like do a contains. Does this thing contain my public key? And it does all the things around it. And inside of like the key entry itself, I'm able to say I can sign something with it, or I can verify something with it. So you're able to do something with the function that's outside of it. Now you compare that to our code that we're doing, like the start code. There's nothing that we're really doing that's special. We're just saying like start an at server or start a wasmCloud process right here. Like we just say ensure wasmCloud. Like we're just starting a process. There's no extra data that's returned with it. So that's a really good question. But yeah, it's you kind of have to feel it out. And I'm hoping we might get to that as we pull over some of the drain stuff. But some of these things are just better as functions because you're doing one task. If you're doing it with like an actual struct and an impl, that means you have some sort of data that gets carried along with the task, or that you need to reuse multiple times.
And then one kind of quick follow up onto that. I know that you're making constants and functions like public to external users. Can you make an impl pub?
Yeah, so an impl itself is not public, but the functions inside of an impl are public. So if we go back here, you'll see that these all have pub labels in front of their functions. Now you can have a couple levels of visibility here. You can have pub, which is obviously completely accessible. You have pub crate, which means it's accessible to anything inside of this crate. And then you have, I think this one I can actually have, no, it doesn't. But sometimes they just have a plain, like, without any pub, it just says FN, like public or whatever. And those are entirely private implementations for the function. And even the crate itself, unless it's inside of the same module, it can't call that private function. So things in the rest of the crate would not be able to call a private function along those things. So that's a good question as well.
Neat.
Okay. So we'll go ahead and we're going to pull up drain. So drain is the next thing we're going to do. So I picked this one because I figured it'd be fairly simple to go ahead and do some of this stuff. This is a command we use when we're just like cleaning up caches and things locally. This is used definitely by developers and also by people who are just trying to like clear out some stuff or debug. That's kind of the common use cases. And we're able to drain a couple different things. Now, luckily, this code is actually fairly well designed, so we're going to be able to pull it pretty much straight over. But what we'll do is I'll say copy this right here. So we have this. Oh, sorry, this is a sub command. So we're not. So we're going to have to change this out a little bit because this is attaching some CLI stuff to it. So this sub command thing is actually from clap, which is a CLI library. So we're going to go ahead and copy this, but we're going to have to modify it a bit. And then we already copied these downloaders function, and then we have this impl that we've talked about, and this has a function that allows us to drain something. So we're going to go ahead and take this, copy it, and we're going to create a new file. So now you're going to see me do this like I was describing at the beginning. So I'm going to create a new file inside of source called drain.rs. I'm pretty certain I'm only going to need one file for this. And then I'm going to come here and say pub mod drain and save it. And so then it knows that it's a module. And the pub mod drain means I'm exposing the module publicly when this crate is out there. And then I'm going to copy paste this. And I know I'm going to need to do a couple things. So first thing, I know subcommand doesn't exist. So I'm going to delete that. Now this derive thing is called a macro. Macros in Rust are really cool. So what this is doing for me is it's adding an automatic debug implementation and an automatic clone implementation. And clone means you're able to take the data and own it. Rust has a strict ownership model. We're not going to go into that too deep right now, but just something that we can keep in mind. And then this, we're going to want to say, you know what, this is pub enum drain selection. So we're going to offer a bunch of different ways for people to do their draining here. Now we can structure this a couple different ways, but I think I'm actually going to keep this as an enum and an impl right now. So I actually don't think we're going to need this into iterator for what we're doing. We're going to just have people be able to call. Oh, sorry, no, we do need this into iter. So this right here is some code that was already written. I was able to copy paste. Now, an iterator is exactly as it sounds. Allows you to have something that you can go through in a list. And what it's doing is it's just kind of wrapping the details behind what this turns into its own set of directories that it needs to drain. So all is going to take all of the directories and put them together. And then lib is just only going to do like the lib directory, like where we're storing the cache, or like where we're storing the OCI cache, or the Smithy models, or all those different kinds of things. And so then we take that and we just take those paths and turn them into an iterator. So it's pretty straightforward how this all works, but we're going to keep this code exactly as it stands. One thing I am going to change here, and we're going to go a little bit into this, is right here we're borrowing a drain selection. We don't actually need to borrow this anymore because people will probably be calling this to look like this. They'll say like drain selection, or I'll probably just call this drain now. So they'll probably call drain all and then do the drain function on it. I think is what that would look like. The other way we could also write this API is we could say we could just have this module have a function called drain, and it takes a drain type or something like that, and then this would be drain it'd be drain type all or something like that. So there's two different ways we can do this. So I'm going to go ahead and just stick with the enum for now, and I'm going to see how I feel at the end, and I might switch it to this type instead. But we're just going to play with it and see. So this is where I just kind of play and see what it looks like as we use it. So we'll keep this as a drain. I don't need these casters anymore. I do need the impl, and I'm going to have to change this so it's not command output anymore. So what I do need is to import that crate that I just created. So I'm going to say use crate config, and I'm going to use model caster and downloadster. Okay, so I have those in there. It allows me to just use all that stuff I created in the config. And I'm also going to change one more thing. So the problem with tempter is, or no, we do want tempter. Sorry, I did that. I said that correctly. But actually, no, I'm going to change this. There's another library that we have called DIRS. Actually, I don't even need to import it. And that has a more like standard interface of like being able to get like the temp directory. Because sometimes when you use like your normal standard env temp directory, there's a bunch of gotchas. So if we do standard, actually I can show this. So right here, this returns a path of a temporary directory. There's platform-specific behavior here. There's just a whole bunch of things. So the idea is somebody created another crate that's called DIRS that we use to access this. So I'm actually going to change this to DIRS. Oh no, I was wrong. See, you're getting me remembering how to code some of these things live. So no, we're going to use that instead. So that is correct. And then down here, we have this drain function. So this drain has a result. And when we look at drain, what kind of result was it? It was an anyhow result. So I think that for what we're doing here, we're probably going to want an IO error because pretty much everything we're doing is cleaning out directories and things. So I'm pretty sure that's going to be all IO errors. So I forgot there's one more function I need to copy, and it's remove dir contents. And we'll put it up here into Dream. Okay, so drain is going to take self, and I'm actually going to say we're going to consume it. So this is once again an ownership thing. For REST APIs, the way I think of it is if this is the last time you're going to use that thing, then you should consume it. That means you take ownership of it. You don't have to borrow any of the data, and that's what I'm going to do here. So for drain, I'm going to consume self. So that means I can do this API that I showed up here in the comments. And my result is going to need to be an IO result. And so I'll go ahead and import. Now, generally, standard practice is you put standard imports on top. Then you put external crate imports. Then you put crate imports at the bottom. So right here, we're going to say use standard standard path. We need a couple things, actually. Path buff, because we're using that below. And then we need a IO result. So we'll do IO result, and we'll stick with that for now. And so down here, we'll say, okay, cleared. So we're going to go self into iter. So that'll get us all the paths that we need from the path buff. It's going to filter and check that the path exists on the directory. And then, so this is another one of those like functional programming things that Rust has borrowed from. So it filters the data, and then it goes ahead and says, I'm going to map each of those into remove the directory contents there, which does the actual removing. And it's going to say fs readdir, fs path. And so it's going to check that first it's able to read the directory, and then it's going to return a result. But in this case, it's doing an anyhow result. But so right here, oops, I tried standard fs. So this readdir gives us a readdir thing that we can iterate through. So it's a result. So we're going to return an IO result here. And then we get the actual entry, which is we iterate over each entry in the directory. And then if it's a directory, we remove the whole directory. And if it's a file, we remove the file. So basically, this is just making sure we clear out both directories and files. Pretty standard file system operating stuff. And then here we're going to say, you know what, we don't need to know like which paths we removed necessarily. So I'm going to just call this a unit type, which is just an empty type. And then this will return OK once it gets to the end. And so up here, when we actually call it, that should remove it. We'll get the result. We're able to return. And here we're going to say this is also a result of this. Now let's think. Now this is where we have to make an API decision. So we can either say all of this was drained, or we can say this is the thing that we drained out. So we can return a list of everything we drained. I'm guessing that that's probably not necessary now, but that's something we could add in the future. So what we have, no, so now this is where so you're getting me live streaming my thoughts too. So now that I'm thinking about it, the first consumer of this is going to be the wash CLI. The wash CLI expects a list of things that were drained to be returned back. So I'm going to change my mind, and I'm going to say we're going to return a string still. And we're going to then take that string and turn it into a vec. So I think we're going to keep that, but we're going to change what the return type is up here.
So Taylor, just to kind of clarify the thought process that you were kind of going through there, you're thinking now of not just like what this method should print out, but like what useful information needs to come out of it so that like a consumer of this could act on it, starting with like the wash CLI.
Yeah, that's exactly what it is. So I have to think about it in terms of consumers when I'm writing APIs. I mean, it kind of sounds like stupid to say it that way, but I'm just saying like you have to put yourself in the user's shoes, and it's very critical when you're writing any library in any language, um, but also like inside of Rust to make this nice and easy to use. Um, Another thing here about API design that I just kind of glossed over is Rust has something called the trait system. And traits are a really, really cool thing that is kind of like declaring like a class in another language, but it's more inheritance, and not inheritance based, but it's composition instead. And so one of the coolest types of traits are these conversion traits that are inside of Rust, and one of them is asref. So what is being done here, and I didn't write this code, but I'm pretty sure Brooks might have written this code. That when we say p asref path, this is saying that anything that can be turned into or referred to as a path, which is like a file system path, can be passed in here. That means in this function, I can pass in a string, I can pass in an actual path type, I can pass in a path buff, I can pass. There's a couple other things that implement path, an asref path, and so I'm able to use any of those types inside of here without defining like multiple types that can be allowed inside of the function. And so even though this is a private function that we're not ever going to export, we're going to go ahead and use it as like make it as easy to use for ourselves as possible. The other thing that is really important here, this is a great example of when we use an impl versus an external function. This external function is something that's getting passed into the map. Now, this is not a hard and fast rule, but a lot of times when you're doing this, this is just like you're trying to make sure you're not passing a whole function into here by itself, because we could do this manually and say, oh, here's my item, and then I'm going to, inside of here, do this whole thing. Now, that's just really clunky to read, and so we separate that out into its own function and makes that easier. Now, the other thing we're going to need is this impl drain. You'll see that right now it's not exported, so we have to say pub fn drain. And then we need to change this type down here to be, okay, we have this hash map. So this is returning it for like a specific command output format, which we don't care about in this library because that's only for outputting, and that should be a consumer's thing. They might be outputting it to all sorts of different styles and things, and we don't want to mess with that. So we just want to give them data that's easy to be consumed. And so I'm actually going to change this now that I'm thinking about it. Instead of it being a string, I'm going to make it be a path buff. Not a path bug, though a path buff. And so down here, instead of formatting this as a string or doing a toString on it, we're just going to say fs remove file path, and we're going to remove okay, so what did I do there and why? So this right here, although for this library it wouldn't matter too much, I try to make great comment too. I try to make this a decision of, do I need to copy data? So inside of Rust, anytime you're copying data. So basically, if you're reallocating something, and in performance critical circumstances, that matters a lot. But I try to follow those rules anywhere I go. So it's called zero cost abstractions is what Rust is going for. So I know exactly what I'm getting, whether it's going to cost me something or not. And here, I have no need to return a owned copy of the data. So in which case I'd actually have to copy the data and into something else. And now I would have the original copy, which could have been a string or a path, and a new copy that's something else. So I'm going to just return this as a list of borrowed paths. And it's going to collect it into this list of borrowed paths right here. And actually, now that I'm thinking about it, that makes less sense. So you learned a lesson, but now I'm going to change my mind because that's what happens when you're coding live. So I'm actually going to make these a path buff, and let me explain why. So I am consuming self here, which means every bit of data is going to get deallocated as soon as it's done. And so what I can instead take is, for this specific instance, because we're not using it anywhere else, I'm actually going to remove the generics, and I'm going to take this and make it a path buff. So oops, buff. And then I'm going to borrow it when I pass it down through here. Oops, not there. There. And then I'm going to return the path. So this means I'm just consuming the data and passing it around rather than like reallocating anything. So this returns a whole set of path buffs. And then inside of here, I'm going to return a vec of path buff and say just do that. So let's see what I missed out on. Oh, I forgot a semicolon because, you know. Okay, so now it's going to give me all the compilation errors. So it says, hey, I don't know what this env is, so I need to bring that in. So I need to do standard env. Okay. And now it's saying, I don't know what this, oh, look, I need a result here. And so this is getting like the model caster, which we did not have wrapped in a result. So we're going to have to change some code here to make this work. So let's go ahead and do that. So I'm trying to think what the best option would be. So if we can't find the model caster, I think the best option would just be to like essentially return an empty path buff. Because if you try to do anything with an empty path buff, it's going to find that it doesn't exist. And so that's probably our best option. Now, this is where Rust has some nice things called, there's unwrap. Now, you rarely want to use unwrap. Generally, if I'm reviewing Rust code and I see an unwrap or an expect or any of those things, I'm immediately going to be suspicious and I'm going to ask and make sure that the code is safe, that you know that you can unwrap without causing a panic. Because if you don't, an unwrap will cause a panic in your code and everything will shut down. So, but what it does do is an unwrap or default. And so that's going to give us a default path buff. And we can do the same thing down here with the unwrap of a path buff. And so that should make that all go away. Okay, and then we're going to get the same thing with downloadster. So we're going to do the exact same thing here. Now, the reason this is okay to do is if you remember down in this drain, it says, does the path exist? So if the path doesn't exist, it's going to just ignore it and then continue on with its life and just say, oh, yep, I succeeded because it completely filtered it out. So we're going to do the same thing here. We're going to go ahead and save it. Okay, that should be all the bugs. So now, one last thing to tidy this up is I need to add documentation. This is another critical thing. So I need to add documentation in two different places. First off, I need to say, okay, what does this function do? Takes a, so I'm going to actually say this drains all, or I'll actually make it clear, cleans up all given all data based on the type of drain requested. Returns a list of paths that were cleaned. Okay, so I have that, and then I'm also going to put it on basically anything public can be done this. And I haven't enabled it yet, but you can enable basically and enforce that all docs need to be there for, or else it causes a compilation failure. And I'm going to say okay. And so now I have all of that. I could probably add some module level documentation here, but there's not going to be too much. So with that, we just ported over just one of the commands over into what will be washlib. So I'm going to pause there. We have a little bit of time, and I can show you how this will now work inside of wash. But I wanted to just pause in case there were any questions that people had.
I had a quick question while they roll in, or while any may roll in, Taylor. So you said that unwrapping, kind of makes your program panic and crash. So what kind of considerations do you have to give when you're thinking about unwrapping something in like kind of your own command line versus a library?
Yeah, so a library should never panic for a user unless you explicitly say that. And the only time I see that is when you're like creating an initial like structure of something, and if something isn't there, you can panic. But you generally document it that way. Outside of that, you do not see panics in libraries, in at least in any well-maintained libraries. They're generally frowned upon. For a CLI, it's much more common to do something like, "Yep, it didn't exist," like because you're at the very end. You're the end consumer. The thing is with something like a crate, like washlib, there could be three other crates using it before it gets to like an end user state, like the actual final person consuming it. So you don't want to ever cause like an error that causes a panic like way deep in somebody's code.
That makes sense.
Okay. I haven't seen any questions yet, so we'll see if we can do this real quick. So I'm going to go back down to drain, and there's a couple different things here. So first off, we have this drain selection, and we've done a subcommand. We're still going to need to have this enum, and it's basically copy pasted. We're going to try to find a way if we can maybe manually like attach some of this stuff down the line, but for now, this is just going to have to be cloned. Now, there's another question that popped up really quick, and whether it's better to expose a trace or just a specific error. For me, it depends on what you can do with it. If it's something that a user can't do anything with, for example, I always think like or no, not this isn't even one of them. I'm just saying a user can't do something with, then I want them to be able to just see that something happened. Generally, tracing is done best in like a consumer of a crate, um, and the crate can log and trace things, but like we don't want to use that just as an error. Most of the time, we use what's called this error is one of my favorite libraries, and we saw that earlier with where did that go? So inside of here, when we were looking at the result type and look at the error, we have this error derived, and I really like this style of errors. You expose all different error cases as an enum, and that allows a user to be able to make a specific decision. So this is things like retry decisions, whether they should bail out. So I always try to provide as much information as possible so that I can react to that error properly. I'd say 80% of the time, I just end up returning the error back up the stack. But the other 20% of the time, I actually use that error to trigger certain logic and behavior. So um, that's a really good distinction to make. So just keep that in mind. That most of the time you want to return like a specific error, and we didn't get to. In this case, we are returning specific errors that are I/O errors. We're knowing exactly what happened when you tried to clean something up. But there can be cases where you want to do more generic, or you can have your own custom errors or whatever it might be. Okay, and then let's see, we have 3 minutes till the top of the hour because I promised only an hour. So let's try and do this. So we're going to go ahead and take. We don't need this anymore because we already have that solved. We don't need the model caster anymore. We don't need the drain implementation anymore. We do need this handle command because it's used by our thing, but we're going to have to adapt our drain to do this command output. So what I'm going to do is just to convert this, I'm going to say impl I need to import a new crate thing. Use crate Sorry, we're doing this as. I need to see how we do this up because I haven't done this. Washlib. Okay, we have imported it as washlib. Just double checking. Washlib, drain, drain. And we're going to say impl from drain selection for drain. And what this allows us to do is to convert it into a type that we know. So we'll say fn from, oops. So, this is one of those things I can tell is not like the bestest thing to do, but I'm going to try to think about other ways of doing it. Basically, I'm going to do the same thing. I'm going to say drain selection, OCI, lib, Smithy, and downloads. Okay, so we've converted. We're able to convert it. So what we'll do is we'll say command, say drain from. You can also use into with this. We'll say drain from command, and then dot drain. And so this will give us our let paths equal. Now this is a case because this is a consumer, a CLI library, we're just turning it into an anyhow because we just want to get the text message back to the user. So we're just getting a vec of path buffs right here. And then the old way of doing this was to get a command output. So I shouldn't have deleted that code. So I could copy paste this. Okay. And so here I'm going to say map insert drained to string, JSON cleared. And so in this case, I'm going to say JSON. I'm taking this is a JSON macro. It turns it into basically a JSON value. I'm going to take paths and turn that into it instead. And then we should be able to just do it that way. And also remove this. And let's see. Paths. Okay. And so it tells us all the things here at the top that we're not using anymore. So I'm going to go ahead and remove those. And we shouldn't need configure or downloads there anymore. We should just need command output. And then I'm going to put these standard imports up at the top. Like I said, this is just kind of standard practice. And then we'll do this one down there. And so now we have the new thing using the library. Oh, and this is why I didn't delete that. So now we have this library all put together, and everything's compiling. I have all my lids succeeding. And you can see that even though we did have to do this kind of janky thing to convert between the new types, we now have something that is way shorter than it was before. Like the actual code itself is 44 lines. And now that code is reusable elsewhere, and inside of the CLI, it's just consuming it. So that kind of brings us to the end of doing like a full how did I refactor this? How did I move about doing it? Um, Brooks, were there any follow-up questions or other things that we should bring up?
Didn't see anything. Didn't see anything in the chat after that last question.
Okay.
But I mean, this is pretty sweet. I think overall, the changes that you added is probably like throughout this refactor is probably going to reduce the lines of code that we have. I think with some of your changes to make it a little more consumable and putting it into one lines, we're probably overall going to benefit with some shorter lines of code, which is nice.
Yeah. Well, and yeah, and thank you so much for the feedback there. I'm glad this was useful. Hopefully people find it useful here. We'll probably do some more of these. Um, we'll see maybe like next week how things are going as well, or maybe later in the week. But these are things that we try to do really well and present out to the community. So hopefully this was helpful for all of you, and hopefully tune in next time for our next stream.